now would be a good time to tweet that this is about to begin in a couple of minutes so that people outside this room can join us on Zoom. So there's a Zoom link for this talk, and the whole world is welcome to tune in. This is going to be an awesome talk. Let's begin. So welcome to the invited speaker session. It is my great pleasure to introduce Scott Aaronson. Scott is Schlumberger Chair of Computer Science at the University of Texas at Austin. Scott has had a remarkable and distinguished academic career. For example, he received the Presidential Early Career Award for Science and Engineering, also known as PCASE, from President Obama, and also the Alan T. Waterman Award, which is the highest honor that the U.S. National Science Foundation bestows on younger scientists. Scott's PCASE citation reads, "For pushing the frontiers of quantum complexity theory and for making the insights from theoretical computer science accessible to the general public." Which brings me to why we wanted to hear from Scott at Crypto. You would think it was because of his work on quantum complexity, and indeed our hidden agenda in inviting him is to ensure that he considers IACR venues for his work in the future, whether on quantum or other subjects. But the topic we have asked Scott to address in his talk today concerns itself with the latter half of his PK citation, namely his engagement in the dialogue between computer science and the general public. In the last few months, the general public, or at least the mainstream media, has been consumed by visions of doom that will befall us all if research in AI proceeds apace. Scott has been an active member of this debate. In fact, for a year now, he has been on leave from his academic position at UT Austin, working at OpenAI on theoretical foundations of AI safety. As cryptographers, we like to think that we can contribute to solving all the world's most pressing problems. So we asked Scott to tell us what these problems are when it comes to AI safety and how our community can contribute to solving them. We're very excited that he is game and can't wait to hear his talk.
Great. Well, thank you so much, Anna. It is one of the great honors of my career that you'd invite me to Crypto to share a personal vision for what crypto can contribute to making AI safe. And that is, it's particularly an honor given that I am neither a cryptographer nor an AI person. I'm like totally unqualified to give this talk. You know, I mean, I've spent decades doing quantum computing, subject that you may have heard also has some relevance to cryptography, but that's got nothing to do with what I'll talk about today, except insofar as quantum and machine learning both involve high-dimensional linear algebra. Now, what happened was that in spring of last year, some people at OpenAI approached me and they said, listen, Scott, we're big fans of your blog. And we're wondering if you would take a year off to work for us on what computational complexity could do for AI alignment. And I said, well, look, you know, I've been as bowled over as anyone by this GPT-3 thing that you've got. You know, I myself, wondered for many years, what would happen if you trained a neural net on all of the text on the internet and built a chatbot that way? And you guys just went and did it. And oh my God, it actually works. But, what do I have to contribute? It seems like, fundamentally an empirical enterprise. And they said, well, we don't really know, but, we think you'll find something. So I said, okay, I'll keep it in mind for some future year. And they said, no, trust us. This is going to be a big year for AI. You want to be involved this year. Of course they were right about that. Chat GPT came out in December. And, that was the moment when the world, which I guess had been distracted by the pandemic or Trump or whatever, finally woke up to this technological revolution that had happened under everyone's noses. Chat GPT quickly got about 100 million users. At the time was the fastest adoption of any service in the history of the internet. And, all of a sudden it was being discussed at every conference, every university department, company, magazine, TV show. As some of you may have seen, GPT was featured in an episode of South Park, where the plot is that the students and then the teachers at South Park Elementary all come to rely more and more on Chat GPT to do everything for them. Doing the homework, grading the homework, writing messages to their boyfriends or girlfriends, until finally the principal of the school has to bring this robed wizard in. And the wizard has a falcon on his shoulder, which flies around the school. And whenever the falcon detects text that was written by ChatGPT, it caws. So now it was weird for me to watch this episode and think like, oh, I'm that guy. Like, my task at OpenAI has basically been to build that falcon. Okay, but before we get into the watermarking problem, let's take a step back and talk about, well, what is AI safety? And, why do some of my friends think that, as Anna alluded to, it's now the most important problem in the world? Does this work to advance the slide? All right. All right. So recently, Boaz Barak, who you all know, and who has also now gotten into AI safety, co-authored a blog post with me where we tried to construct the analog of Impagliazzo's 5 worlds, but for AI rather than for cryptography. So instead of mini-crypt, heuristica, and so on, we have AI fizzle, which is the world where, we're just bottlenecked by training data and AI never gets much more impressive than it is now. And then we have worlds where AI transforms civilization, but humans are still basically in charge. And depending on whether you judge it to be good or bad, we can get either the Futurama world or the AI dystopia world. And then finally, we have the worlds where AI basically succeeds or replaces biological humans as the main driver of the future. And again, you could imagine that as either extremely good, in which case you get the Singularia world, or extremely bad, in which case you get the paperclip-ellipse, which is the world where some unaligned super AI starts converting all of the matter in the universe into paperclips or whatever other ridiculous goal function it has. Okay, so now if the stakes are potentially, literally cosmic, then, presumably we should put at least some thought into how to ensure that this goes well. So that brings us to the rapidly growing field of AI safety, which has 2 main branches, known as AI ethics and AI alignment. Now, you might hope that everyone would just pull toward the same goal of making AI safe. But alas, these 2 branches basically hate each other. They're kind of like in Monty Python, like the People's Front of Judea versus the Judean People's Front. So basically, AI ethics people are the ones who are worried about the AI dystopia scenario. So about near-term harms, misinformation, propaganda, job loss, powerful people basically using AI to amass even more wealth and power for themselves and to oppress the vulnerable. AI alignment people are the ones who are more worried about the paperclip-ellipse, about the longer term future where AI, they believe, could become to us, as we are to baboons. And then, maybe they would treat us about as well as we treat baboons. And, so the AI alignment people would say, well, it's not at all about which humans get to control the AI. Either we all succeed collectively in building AIs that value human welfare, or else we all fail. Okay, so where do I fit? I like to call myself a reform AI alignment person. So, I am worried about the long-term future. I see nothing in physics or CS that would make, this AI takeover impossible. But, 25 years in CS theory has also taught me the need to pick off subproblems that you can make actual progress on, and where you can get feedback from the world. So from math, or numerical simulations, or experiments, or real-world deployment about whether you're succeeding or failing. So my hope is that, by addressing the near-term misuses of AI, we'll gain knowledge, some of which will be relevant to the long-term alignment problem, hopefully. Okay, which brings me to this talk. So my thesis is that there is a tremendous opportunity right now to make progress on AI safety, in particular by thinking about cryptographic functionality that could be put on top of or inside of neural networks. So this, call it what you want. I thought to call it neurocryptography. A better name is welcome. Might actually be a large fraction of the future of cryptography. In addition to the technical challenges, I think that there are also huge conceptual challenges, and I'll talk about some of them in defining the right attack models. And there are also social challenges, okay, in coordinating the different AI companies to deploy whatever solution one comes up with. Okay, so, there are lots of examples of neurocryptography, many of which, many of you are probably already familiar with. One that I've thought about a lot, and that I'll spend a large fraction of this talk on, is the problem of watermarking. So how do we make the outputs of a generative AI identifiable as such? A second example that I'll talk about is cryptographic backdoors. So can we insert secret inputs into an AI by which to recognize or control the AI later? I mean, backdoors could also be a bad thing, but they can be a good thing as well. Okay, so then there's, privacy preserving machine learning, protection of copyright, obfuscation of public models, all of which deal in different ways with can we protect the training data and or the model weights from people who we don't want to have access to them. And many of these topics have been discussed at this very crypto and at the affiliated workshops. And, there are people here who are far more expert on these things than I am. So I won't focus on these, due to lack of time, but happy to do so in the discussion period. And then, I actually asked GPT-4, what else should I include on this slide that I forgot? And it suggested, well, what about zero knowledge proofs of properties of machine learning models? Or what about robustness against adversarial examples? So I said, yeah, that's good. I'll put that on the slide. Okay, so let me talk a little about this attribution problem. So you've all seen these headlines, right? The world has now had a semester where probably a significant fraction of all of the homework on Earth was done with the help or entirely by ChatGPT. ChatGPT use actually noticeably went down at the beginning of the summer. If it goes back up in a couple of weeks, then we'll know the cause for sure. Okay, so so there is this academic cheating issue, but there's a more general insight here, which is that almost any nefarious near-term use of large language models that you could possibly think of, whether it's spamming every comment section with pro-Putin propaganda, or fraud or spam, it all involves in one way or another concealing the involvement of a large language model. And so you might think, well, if only we could make that harder, then we would head off all of these different misuses at the same time. And there's even a separate reason beyond that to care about this attribution problem. Namely, as the internet gets filled more and more with text generated by language models, we'll often need to prevent that text from getting fed back into the LLMs as training data, which would sort of be biting our own tail, and making the models diverge further and further from the human behavior that they were supposed to emulate. Okay, but that requires first recognizing, which text is LLM generated. Okay, so there are many different proposed solutions to this attribution problem. I mean, sometimes you can just tell whether a language model wrote something by eyeballing it, right? Infamously, this semester we saw hundreds or thousands of homeworks turned in that contain text such as a large language model trained by OpenAI. I mean, I have gotten dozens of troll comments on my blog that I'm basically certain are LLM generated, right? And I don't need any watermarking for that. I can just look at it and see the style. Okay, but that doesn't always work, and we should expect it to work less well as the models get better. Okay, there's a lot of discussion right now about adding metadata to AI outputs, including by government regulation. Now, adding a digital signature, for example, to an AI output could help prove that yes, this did come from this model, right? But as I don't need to explain, that doesn't really help for the opposite direction, right? Because especially with text, any metadata would be trivial to delete. Okay, now another idea is that OpenAI or whoever operates the language model could just store in a giant hash table, possibly encrypted, everything that the model has ever generated. And then if you want to know whether GPT generated something or not, you would be allowed to make queries into that hash table. Okay, so, I've thought about this along with others. I was unable to prove any theorem that I was satisfied with, saying that, the privacy of people's conversations with GPT would be safe from attack this way. Maybe one of you can prove such a theorem. I think, there's a further difficulty, which is that, even if you could prove such a theorem that says that sort of privacy is preserved this way, well, in practice, once you make, the entire log, the entire history of your language model sort of available for queries, you expose it, then any kind of bug in implementation could be a catastrophe for privacy. And I think people would realize that and they would be scared about it. Okay, so this is a potential solution to have in mind, but maybe we should look for others. Now, another solution that's been pursued is to treat this attribution problem as simply yet another AI problem. So you train a discriminator model to distinguish AI from human text as well as it can. That's what was done by Edward Tien, who was an undergrad at Princeton, who created a tool called GPT-0. And I understand that his server crashed right afterwards because of the enormous number of teachers and professors desperate to use it to see whether essays were written by GPT. OpenAI put up its own variant of that called Detect GPT. There's a more recent one called Ghostbuster. Okay, but as we have now learned, the problem with discriminator models is that their rate of false positives tends to be too high. And in fact, OpenAI took Detect GPT offline for that exact reason. Okay, so you can get these models to say that passages from Shakespeare or the Bible, for example, were probably AI generated. I mean, it's a kind of text that's, a little bit outside the normal distribution, it gets a little confused. But, there have already been students who were falsely accused of cheating using language models, apparently partly on the basis of these discriminator models. Okay, so, and this brings up an important point. False negatives can be okay, but in any solution to this problem, we really, really want the rate of false positives to be very, very close to zero, right? And with a discriminator model, you're fighting a moving target, right? Even if you had a low enough false positive rate right now, then what about when the model improves and it gets better at emulating humans? Okay, so that brings me to watermarking, which means slightly modifying the way that the language model works. So not modifying the neural net itself, but modifying sort of the code around the neural net to insert a statistical signal into the choice of tokens that are generated by the language model. Tokens just mean, words, parts of words, numerals, punctuation marks. They're the everything a language model generates or reads is treated as a concatenation of tokens. There's about 100,000 of them in GPT. So you modify the choice of tokens somehow to insert a signal which can later be detected. Okay, now this is related to the ancient idea of steganography, or inserting hidden messages into text. There's even been formal work on steganography in the crypto community. From our standpoint, the trouble with steganographic schemes is that they tend to be very non-robust to changes to the text, whereas we want something that is extremely robust to changes. We'll talk later about exactly what we mean by that, okay? But also, it's not as if we are given a text and then, we have to modify it to insert a secret message into it. Like in any solution, we ought to take full advantage of the fact that our neural network, in our language model, is actually outputting probability distributions, right? It's given each sequence of tokens, it's outputting the probabilities for each of the possible next tokens, okay? We ought to use that somehow. Okay, so let me give a very brief history of, this problem of watermarking large language models. In AI safety, I find you're constantly asked to prognosticate decades into the future, okay? I can't do that. My record is that I was able to see about 3 months into the future. So last summer, before there was ChatGPT, I had these really dedicated trolls on my blog, like impersonating my colleagues and stuff like that. And, it gave me this moment of terror. I realized, like, oh my God, GPT is going to make this so easy to do, isn't it? And so then that motivated me to, come up with a way to watermark the outputs of language models. I came up with, what seemed like the right way to do that using pseudo-random functions and a certain rule that I'll show you. And then people in machine learning told me that I had rediscovered something called the Gumbel softmax rule. So, okay. So, then I proved theorems about that scheme and I gave talks about it. And I worked with an engineer at OpenAI and we did a test implementation of it. Now, most of the ideas that we had were later rediscovered or even superseded by various academic groups over the past year. This whole field just moves so quickly. I can't, I need to go back to the slow-paced world of quantum computing, okay? But so in January of this year, Kirchenbauer et al. At Maryland proposed a way to watermark by pseudo-randomly modifying the LLM's probabilities. And this was actually a best paper award at ICML, I think. The disadvantage of that approach compared to ours is that for all we know, changing the probabilities might degrade the quality of the language model's output. Whereas I really wanted outputs that were cryptographically indistinguishable from the normal language model output. Okay, so then this June, Miranda Christ, Sam Gunn, and Or Zamir. Sam Gunn was worked with me as an undergrad at UT Austin, now at Berkeley, but they rediscovered the key idea of my scheme, although they implemented it in a different way by reducing to the case of 2 tokens rather than by using Gumbel softmax. They didn't care about constant factors, which I did, figure that. But they did care about cryptographic indistinguishability against an adversary who can make multiple queries to the language model. And I just cared about indistinguishability against one query because I thought, okay, we're not trying to hide the fact that watermarking is happening, right? We just need a statement that the quality of the text is not going to go down. Okay, but they actually went further. And then more recently, last month, Kuditapudi et al. Proposed yet another way to watermark language model output. In their case, they used a one-time pad rather than a pseudo-random function. Okay, so there's been a lot of ideas. But let me now define the problem that we're trying to solve. Okay, so we, in the watermarking problem, we're given a sequence of tokens, call them W1 up to WT minus 1, which, are either part of the input prompt or part of the, response, the completion generated by the large language model. We are also given a probability distribution, call it PT1 up to PTK over WT, which is the next token, the tth token to be output by the language model, right? And this is what the transformer neural network outputs. It's basically these probabilities or their logs. Okay, so this is what a language model does over and over. Okay, and in normal operation, all you would do would be to sample the tth token from this distribution, then feed it back in and then just continue in that way. Okay, there are alternatives. For example, if you set the temperature parameter to 0, then you're telling GPT to always pick the token I that maximizes PTI, right? So then you're making it deterministic. Okay, now though, we want to do neither of those two things. Okay, what we want to do now is to pick the tth token in a pseudo-random way. Okay, so we're going to assume that we've got a pseudo-random function, call it f sub s, indexed by some key s. Okay, and our pseudo-random function takes as input a C-gram, so just a sequence of C consecutive tokens, including our candidate tth token, I, and it outputs, it will be convenient to assume, a real number, RTI, which is in the unit interval, okay, between 0 and 1. Okay, now our goal is to choose the tth token I in such a way that it looks like it is drawn from this distribution. Okay, but secretly it will be boosting some score that we can later calculate, if we know S, if we know the seed of the pseudo-random function. Okay, and we'll implement that by just choosing I's that boost, that favor large values of these pseudo-random numbers, RTI. Okay, now what about the detection phase? Okay, here we're given a text and we have to decide whether it came from the language model or not. Okay, so here, we'll have access to a document, let's say W1 up to WN. Okay, and because we have these tokens and because our RTIs are just these pseudo-random functions of the tokens, we can calculate these RTIs. Okay, so we know these also. But crucially, we do not know the probabilities PTI at detection time. Okay, why don't we? Well, because the probabilities could also depend on the prompt. Okay, and we cannot assume that we know which prompt was used to generate this document. Okay, so given this setup, it's now simple to state, what I think is sort of the natural thing to do, or what turns out to be. Okay, so at each position T where a token could go, what you want to do, I claim, is choose the token I that maximizes RTI to the 1 over PTI power. Okay, so what's going on with that? What is that? All right, well, let's give some intuition first. Okay, so intuitively, the smaller some probability PTI is, the larger is the exponent, 1 over PTI, which means the closer this real number RTI has to be to 1 in order for RTI to the 1 over PTI to have any chance of being the maximal one, right? Which means that I is less likely to be chosen, which is what we wanted since PTI was small. Of course, that's qualitative. There remains something to prove there. Okay, but in the detection phase, my proposal is just to calculate the sum over all of the C grams of tokens of this quantity here, log of 1 over 1 minus RTI. Okay, and then if that sum exceeds some preset threshold, then you say that the document probably came from GPT, and if not, then not. Okay, and there's also a way to modify this to try to identify which portions of a longer document were written by GPT and which were not written by it, which is an interesting dynamic programming problem. Okay, but just talking about the basic scheme. So what properties can we say that it has? Okay, well, first of all, there's a very low computational overhead, on top of the language model itself, the inference of the language model. I've talked to people in crypto who have asked, well, if we can do obfuscation or homomorphic encryption, and there's only a factor of 1,000 overhead, is that okay? I said, okay, I think I'm a theorist, but I think I've learned enough from OpenAI to say no, that's not okay. Not even a factor of 2 overhead is okay. A fact, 1 plus epsilon is okay, right? And this gets that. Okay, now crucially, we also have a robustness against local perturbations. So even if someone changes some words or changes the order of sentences or paragraphs, the watermark will still be detectable as long as a large fraction of the C-grams are preserved, right? Why is that? Because the score we're calculating is just a sum over C-grams, right? And so, the trade-off here is that the smaller is C, the more C-grams will be preserved as the document is modified. But also, the smaller is C, the easier it might be to detect to distinguish the watermarked output from normal output. Okay, so in our experiments, we took C to be 5. You could play around with other choices. Okay, and then we have this really crucial property of indistinguishability. Okay, so the output of the watermark model is going to look exactly like normal output of the language model, except to someone who is able to distinguish this F or F sub S from a truly random function. Okay, and why is that? Well, it just rests on a simple technical claim, which is that if we supposed that the RTIs were uniformly random, so that each one was just a real number chosen uniformly, from the unit interval. Okay, then I claim that the probability that the ith token would get chosen would always be exactly PTI. Okay, and once I've set all of this up, like I could give this as a homework exercise, right? Maybe I will even. Well, I mean, if you want to like super quick, you can see the proof that's on this slide. But it uses when you take the logs, the Gumbel softmax rule is equivalent to minimizing this quantity here. This is an exponential random variable with a mean of 1 over PTI. And then we just use the basic properties of exponentially distributed random variables. So, we sort of just started with the behavior that we wanted, and then we worked backwards to get the rule that would give that behavior. Okay, but one thing that I haven't talked about is the role of entropy. Okay, so all of, the entire possibility of watermarking depends on the fact that language models are probabilistic, right? They have multiple choices that they could plausibly make. They have a garden of forking paths, and we can, try to steer things, within that garden without being noticed. Now, suppose that you ask GPT to list the first 100 prime numbers, for example. Okay, well, of course it can do that, try it. But how would you watermark the result? Right? I mean, except maybe by inserting some hidden spaces or hidden formatting or something. Okay, there's any problem with a single right answer, there's basically no possibility of watermarking it. But also, we don't care that much anyway, right? Because the task was obviously hopeless. Okay, so what this is telling us is that the number of tokens that are needed to get a strong watermark signal is going to depend on the average entropy per token, okay, conditional on the previous tokens, as perceived by the language model itself. Okay, so so we can define this quantity, which I'm calling alpha, which is just the average over all of the locations for a token, of, the Shannon entropy in NATS of the distribution that GPT computes for that token. Okay, and what we're saying is that the more entropy there is per token, the more possibility there is to get a watermark signal, and therefore the fewer tokens we should ultimately need. Okay, of course, one can be more quantitative about that. And you can just do a calculation about what does this watermark score do, right? And there's one thing that it does for sort of normal text that is not watermarked. It turns out to have a mean of n and a variance of n if there are n tokens. And then there's a different thing that it does for text that is watermarked, right? For text that is watermarked, we are systematically favoring larger values of RTI. And therefore, we are sort of biasing this sum to be larger. And the amount that it's larger turns out to be at least this. So it's n plus alpha n, alpha being that average entropy, times, and I just couldn't resist including this. I just enjoy this. Pi squared over 6 minus 1 is the constant you get. Okay, and so then, this just turns into a standard statistical discrimination problem. So, you have two normal distributions, one corresponding to non-watermark text, the other corresponding to watermark text. And now the goal is just to get these two Gaussians far enough away from each other, that their tails have a small enough overlap. Okay, and the bound that you can work out, it turns out to be if alpha is the average entropy per token. So, imagine that as 1, maybe, or maybe less than that, maybe 0.1. And if delta is the probability of a misclassification that you are willing to tolerate. So imagine that as, let's say, 1/1000th. Okay, then the number of tokens that you need to distinguish whether there's a watermark with error probability at most delta is going to grow like 1 over alpha squared. Okay, that just comes from these variance bounds, times the log of 1 over delta. Okay, empirically, with a few hundred tokens, you typically already get a pretty good signal. And, with a few thousand tokens, you get an extremely strong signal. Okay, but now this is a cryptography conference. So what about attacks against this scheme? Okay, there are many attacks that, one could think of. Modifying the document, word by word until it no longer triggers the watermark detector if you have access to it. Okay, but there are even more devious attacks than that. Okay, so, imagine a student who asks ChatGPT to write their term paper, but in French, and then they put it into Google Translate. Okay, or, here's an even simpler attack, which was proposed by a guy named Riley Goodside. He said, look, let's say, you ask GPT to write your term paper, let's say about feminism in Shakespeare, but insert the word pineapple between each word and the next. Okay, and GPT-4, unfortunately, is smart enough to do that, right? It will do that, although, like here, although when I tried it, one time when I tried it, it within the essay itself, it started talking about, gosh, all of these pineapples are really interfering with the legibility of this document. So I guess the student would have to notice to take that out. Okay, but after having done that and having deleted all the pineapples, they'll then get a document which is completely different from the one that was watermarked. Okay, so how could we defend against this sort of attack? Well, there are a few ideas. You could just treat this as a cat and mouse game, similar to Google's decades-long battle against SEO, right? And you could just try to be a better cat. So you could add filters that try to notice when someone is trying to evade the watermarking, or when some website is set up to try to evade the watermarking and block access to those things. You could try to watermark based on non-local collections of tokens, maybe using the attention heads in the transformer model to find those things. But that would defend against some of these attacks and not all of them. I think that my view is that ultimately what you want to do to if it is possible to defeat all of these attacks, then it's going to look something like watermarking at the semantic level rather than at the syntactic one. Okay, so inserting a watermark at the level of the underlying ideas in the document, ideas that would survive even translation from one language to another, or all sorts of other, sort of surface transformations of the document. Okay, I mean, how could that work? Well, one thing that we know about transformers is that they represent, tokens using vectors in some high dimensional vector space. And so what we could try to do is toggle these vectors around in a way that inserts a signal that we can detect later if we know what to look for. But, such that someone who doesn't know what to look for will not notice anything different. So for example, we could pseudo-randomly choose a whole bunch of subspaces in our vector space. And then we could say, inserting a watermark means nudging our vector so that it is on the correct side of a large fraction of these subspaces. Now, the tricky part is that then we also need to take the words, we need at detection time, we need to be able to map them back to vectors, and the watermark has to be preserved by that, at least well enough for us to be able to detect it. So this is an empirical question. I don't know how well this will work. I sort of despair of being able to prove any theorems about it. So yeah, so like Santa Barbara, maybe, you nudge it a little bit and it becomes a related concept. Okay. There are actually ideas closely related to this that have already been explored for the problem of watermarking images. Okay, so there's a very recent paper by Wen et al. Again, a group at Maryland, something that they call tree ring watermarking. Okay, where this applies to diffusion models such as Stable Diffusion or DALI. And what they do is, so diffusion models start with like a random Gaussian noise image. And then, they use this vector representation of the prompt that you typed in to slowly transform that into the image that you want. And so they insert a watermark into the original Gaussian noise image. And then they show empirically that they can often detect that later, and that it resists all sorts of sort of surface level modifications to the image. So my hope is that something similar to that could also be done with text. When you manipulate the vector representations of the concepts. And you can even get more ambitious if you like. You could say, look, if we are going to open the black box and sort of watermark at this sort of internal level, then could we even watermark a public model? Okay, so could we publish the weights of a model and still have it be the case that this model will insert a watermark into all of its outputs and no one will easily be able to remove it? Okay, and maybe the detection is also public, as long as we're asking, why not? Right. I think, these are questions where, the crypto community clearly has a lot to say about, if you need, indistinguishability obfuscation and all these things that add enormous overheads, then maybe it's not practical. Okay. But, the ideas in this community can inspire things to do that are practical, as we've seen happen again and again. Okay, but now I want to step back and ask an even more basic question, which is, what is even the security definition, right? Like I showed you some attacks against watermarking, which involved changing, turning in a different essay than the one that GPT generated, but, where they were related by some trivial transformation. So you could ask, what is the set of all transformations that we are worried about here? Okay, and when you try to formalize this, you come up with things like, well, you would like to detect if an AI made the main creative contribution to this text. This is the kind of thing literary scholars argue about, right? Like who really had the ideas, right? I mean, if the student just used GPT to get ideas and then they wrote their term paper themselves, that seems fine, right? But, at what point does it actually become cheating? At what point, is the student really relying too much on the AI model? Well, if we would say that they relied on it too much if they modified the AI output in at most trivial or uncreative ways, such as deleting pineapples or, translating from Pig Latin or something. Or maybe, if there are arbitrary choices in the text that was turned in, which are present only because an AI happened to make those choices, not because, the human would have made them. Or if, the human cannot explain or justify the choices. How do you test that? Well, the low-tech method is to just call the student into your office and ask them. But, it would be nice to say something better than that. And I would forgive you as cryptographers for, seeing, these notions and being like, asking again, what is the security definition? So, I've talked about this with others in the AI safety world for a year, and we haven't been able to come up with any definition that we are happy with. And so I give that out as a challenge to you. Okay, so but having said that, the scheme that we have, it might already be good enough to catch like 90% of academic cheating, right? Just like there are, ways to prevent software piracy, right? That are not very principled or very good, but they may be good enough that 90% of people will just pay for the software, right? And it was indeed decided 40 or 50 years ago to, that the triviality of pirating would not, just prevent there from being a software industry. Right. So okay. So can we actually deploy this and see what happens? So as I said, a prototype of my scheme was implemented by an engineer at OpenAI named Hendrik Kirchner. Seems to work. So why hasn't it been deployed yet? Well, I can tell you some of the questions that have come up over the last year. So an obvious one is, will customers rebel and say, well, this is Big Brother. I don't want, the outputs to be watermarked, and then switch to a competing language model. Okay, so, there is a competitive risk in doing this that makes product people, not like it. And so that leads to a natural next question, which is, can we get all of the different AI companies to coordinate around safety measures like this one? Okay, so some of you might know there was a White House summit just a couple months ago where the main AI companies all agreed in principle to a bunch of safety measures, which included watermarking of generative AI outputs. All right, so that sounds good. Hey, but if you read the fine print, it's only watermarking of audiovisual content rather than watermarking of text. Okay, so, can we get everyone to agree that this is a thing that makes sense? Okay, and then I got objections, that were like just totally outside what I had thought about. People said, well, aren't there users who should be allowed to use a language model without disclosing the fact that they are doing that? For example, what about English as a second language speakers who are using GPT, millions of them now, to improve the fluency of their writing? Isn't it unfair to them if everything they write is going to get like flagged as, this came from GPT? All right, well, that's a question. I don't know how to build a watermarking scheme that only works for unsympathetic cases and not for sympathetic ones. And then there's a really crucial question of who should get access to the detection tool. Okay, so, you can control that by just choosing who gets access to the secret key, S, right? And the choices are everything from, well, only OpenAI itself gets access to the tool, to the entire world gets access to it, either because the detection tool is available by a public interface, or maybe even the key is public. Or you could say access will be parceled out to those who are considered to have a legitimate need for it. So maybe like grading websites like Canvas and Turnitin.com, okay, or journalists who are researching misinformation, right? But then you have to, have some office that, controls who gets access to the detection tool. Okay, so in my last few minutes, I wanted to say a little bit about a sort of cousin problem to watermarking, which is the problem of cryptographic backdoors in machine learning models. Okay, so there was a really beautiful paper a year ago by four cryptographers, Shafi Goldwasser, Michael Kim, Vinod Vaikuntanathan, and Or Zamir. It was called Planting Undetectable Backdoors in Machine Learning Models. And this paper was a beautiful proof of principle that it is possible for a theoretical cryptographer to say something that addresses actual machine learning models, right? This is not doomed to be just entirely an empirical subject forever. And so here would be my statement of their main result, or one of their main results in this paper. They said, suppose that you control the training data of a particular kind of neural net, which is a depth 2 network of ReLU gates, right? Just a particular nonlinear activation function, and the initial weights in the neural net are random. Okay, then in this special case, you can insert a backdoor. Okay, you can cause, in other words, you can cause there to be a secret input that makes this network just go crazy, like output a totally wrong answer, right? Where you will know, how to trigger that, how to find that secret input. But if you can now publish your model, publish the weights, and no one else will be able to find that secret input. Or rather, in order to do that, they would have to solve the planted clique problem, okay? Finding a planted clique in an Erdős-Rényi random graph, which we have at least some intuition that it should be hard. Okay, so it's a major technical problem already. Can we generalize this to more realistic neural networks? So what about higher depths? Language models might have depth of 50 or 80 rather than 2. And now intuitively, you would expect that as a network gets deeper, its behavior should only be more inscrutable, right? Which means it should only be easier to insert a backdoor into it. Okay, but you sort of lose theoretical control, and it becomes much harder to prove anything. Okay, that's the difficulty. So there's a problem already there. Okay, but the point I want to make is that in their paper, Goldwasser et al. Considered this the ability to plant these backdoors into ML models as sort of a lemon. It's like, oh, woe is us. That a bad person could put in this backdoor, and we would have no way of detecting it unless we could solve planted clique. Okay, I want to point out that, as often happens in CS, the lemon could be made into lemonade. Okay, so an undetectable backdoor could actually be great for AI alignment. It could give us a means to identify and control and maybe even shut down a powerful AI, which only the human creators of the AI would know about, and which even the AI would not know about itself, even assuming that it can examine its own weights. Okay, unless it can solve, a cryptographically hard problem. Okay, a version of this idea was in a paper by Adi et al. In 2018, where they wanted to use backdoors to insert watermarks, by which you can prove later that yes, this model was really your model. Okay, but it could be used for other purposes also. So you might say, like, one of the earliest problems that was studied in the AI alignment field was the off switch problem. Okay, how do you just have an off switch for your super AI, where if it ever gets out of hand, then you can switch it off, pull the plug or whatever, right? And that seems simple, but the alignment people would quickly point out that any AI that's intelligent enough, it'll have some goal. It will know that it can only achieve that goal if it's still on, and therefore it will take measures to prevent itself from being turned off, such as making copies of itself, or convincing you not to turn it off, or disabling its off switch, or whatever. Right, so how do you put an off switch into your super AI? Okay, so here's the idea. What about a cryptographic off switch, right? That not even the AI itself knows about. If nothing else, I think that this could be a great basis for a science fiction novel, right? Like the killer robots are running amok. There's only one person who knows the secret back door for shutting them off. Or maybe there are 7 different back doors that have to all be found, like, Voldemort's Horcruxes, and they're, anyway. Okay, well, what I wanted to say is that the method of Goldwasser et al., even if we could generalize it to higher depth neural networks, it would not immediately work for our purpose, because we need not just an undetectable backdoor, but an unremovable one. Okay, and so now if you think about an AI that's worried that it contains a backdoor and wants to modify itself to get rid of that backdoor, right? There are at least 2 obvious things that you might do if you were that AI. Okay, the first thing you might do is you might just train a second AI to pursue the same goals as you have, but which would lack the backdoor. Okay, the only good thing to say is, well, at least such an AI, if it tried to do that, it would face its own version of the alignment problem, namely how to align that other AI to itself. And maybe that's hard, and maybe it doesn't want to bother with that. Okay, but there's even a simpler response, which is the AI could just encase itself in a little wrapper of code that says, look, if the neural net ever outputs a command to shut myself down, overwrite that command by stab the humans harder. And so okay, the only good thing to say here is, well, if for example the AI wanted to shut itself down in some cases, or if it might want to, then it might not know whether a given thing was a backdoor or not. It might not know whether it should overwrite this. So I'm going to give another challenge to the crypto community, which is to come up with a formal definition of an unremovable backdoor, which is not just immediately killed by these attacks. Okay, the best that I've been able to come up with in this direction is to say, well, if we suppose that the model has some backdoor-like behaviors that it likes, that it has some quirks of its behavior that it wants to preserve in itself, as you might have quirks of your behavior that you would like to preserve and and not just get rid of, then can we also insert a backdoor that the model doesn't like, and have the model not be able to do anything in polynomial time that would remove that backdoor without also removing the behaviors that it likes? Okay, so let me summarize. So whether or not it can stop the robot uprising, which, I don't know, cryptography can clearly, I think, play a role in mitigating near-term harms from generative AI, from cheating to fraud to theft to privacy violations. This includes all sorts of approaches, from watermarking to backdoors to privacy-preserving ML, adversarial robustness, and much more. Typically, you can't just take existing cryptographic protocols and layer them on top of a neural net, for example. And the reason is not only because of inefficiency, but also because we now have goals that are conceptually new. And I showed you some examples of such goals. Okay, and now as for what this whole emerging area should be called, I suggested neurocryptography. Maybe some of you have a better name, but when I asked around, the one other suggestion I got was deep crypto. And I'm going to venture that neurocryptography is a better name than that. All right, so thanks for listening.
All right. Questions?
Give you an example of something with a unique answer that would be very interesting to watermark. And the answer is to a question like, what is the top nuclear command and control key of the U.S.? Pick some cryptographic analytic problem, and there are a bunch of artificially intelligent cryptanalysts. You'd like to know which one broke the system.
Yeah,
The
I
answer
mean,
will be, a few hundred bits.
yeah, there does seem like a conceptual problem. How do you watermark any solution that is unique, right? Because the very fact that it's unique means that anything that gets the answer right was going to find that exact same solution.
Let's switch over to this side.
Just a simple question about watermarking. I mean,
Hmm?
normally when we think about applications of LLMs, we think about, I think most people think about short prompts and long answers. And now recently, I mean, LLMs have become good enough that they can work with tools, that they can generate code and so on. But there can be self-prompting techniques, and these can very easily cause giant prompts that sort of are generated internally by the model.
Yes.
Does that make the watermarking problem substantially harder?
Uh,
For instance, I mean, in the pineapple example, one could extract the model to generate a text that contains pineapple and then generate code that takes the pineapples out again.
Yeah. So with the approach that I talked about, the length of the prompt just doesn't matter, right? Because we don't even need to see the prompt or any probabilities that depend on it at detection time. There are other possible approaches that you could imagine where you explicitly try to guess the prompt, or work backwards and figure out which, if this came from an LLM, then which prompt is likely to have generated it. And for those kinds of approaches, certainly shorter prompts would be easier to handle than longer ones.
Thank you, Scott. Great talk. So
Thanks.
I have a question. How robust is the system against another neural network that its own goal is to de-watermark systems?
Yeah, that's an excellent question. I mean, if the other neural net is powerful enough, in the limit, you would say, well, it's just like a new language model, right? And of course, it can, remove any watermark that we add, right? And and then your only hope is that the AI companies have coordinated so that other language model is also watermarked, right? But if you use sort of weak language models to do the rephrasing, then there's actually some recent experimental work by Tom Goldstein's group at Maryland that says that like weak rephraser models tend to preserve a large number of bigrams and trigrams from the original document. And as long as that's true, then you still get the watermark.
Great, thanks.
Thanks for the great talk. More of an ethical question. So this kind of the development of cryptography has a very distinct moral feeling compared to at least how I perceive traditional cryptography as like a fundamentally subversive tool, something that the people, like something that stands with the people against government or establishment, or like in spite of government or establishment. And like this instead feels very much like an authoritarian turn of events, where the tools that we are developing with like watermarking or with DRM are against the people.
Well, I mean, it depends which people, right? So here's the thing. Like, there are millions of teachers and professors who are desperate for a solution to this problem, right? If you did watermarking that was effective, then you would make a lot of teachers happy. You would make a lot of people who, are going to be targeted by scams or misinformation, you would make them happy. On the other hand, you might make some users unhappy. Okay, so that is a trade-off. And, I can't answer that ethical question. Only you can answer, you can come up with your own answer to it, right? I can try to lay out what is possible and what is not. But, for me, the balance of considerations, seem to be in favor of, if you can do something that is going to not harm legitimate users and is going to make all these, nefarious uses, including by governments, like spreading propaganda and stuff like that, it's going to make those harder, then yeah, maybe that's a win. Maybe we should do that.
Thanks.
So I wanted to kind of call it a sort of an ethical question here about AI safety, AI ethics, because you can start talking about we want AI to behave in certain ways. We want to protect ourselves from, misuse of AI. But what you're talking about here, the main application you're talking about here is effectively protecting almost like a business model. In a lot of schools, a lot of classrooms have gotten used to the idea we can have students write an essay, and that's how we'll find out if they're doing well. And the main, and everybody understands that essays, especially like college application essays, are often written by somebody who's being paid. And the problem that we actually seem to be addressing here is the cost of having somebody write your essay went down, right? That instead of me paying somebody to write my essay, instead I can just do it with like ChatGPT, and it doesn't cost me anything. The bigger issue here, because that's a small thing, the big thing is it seems like there's a danger that the work on AI safety or AI ethics will be drawn toward protecting the business model, protecting the current way of doing things of existing organizations and governments, rather than solving a problem of, is this AI actually dangerous to us?
Okay.
See what I'm saying?
Yeah. Two comments on that. One is that OpenAI has, as I said, resisted deploying watermarking for a year because of, in part because of potential danger to the business model. If you, to the AI business model, if you do something like this. I have heard sort of a surprisingly large number of times, well, why isn't the solution to this problem just to let homework die? Just to get, just to abandon the idea that, students are supposed to produce work that is their own, and that, just let them rely on language models. Maybe the world will eventually evolve that way, but I don't feel like that is, that it's the place of AI companies to be making that decision unilaterally for everyone.
Well, I just kind of think of this in terms of, okay, you could make the students write the essay in person. And I think no colleges do that because it would be extra work, it would be expensive.
Yeah.
But, that's already accepting, okay, lots of the application essays were written by somebody who's paid. And that's
right. Or, we might move to a world where people say, yes, of course I use ChatGPT to help me write this, and what of it, right? And it's not even a stigma at all. But, in any case, if we can avoid sort of forcing a social change on people who don't want it, then maybe we should.
So James and Nadia have been waiting a long time to ask their questions, but I think those two will be the last ones.
Okay.
Sorry.
Most of the people in this community use products like Grammarly to help edit their documents to make them sound better. As those products start using AI to help write documents, your documents are going to be called out as being written by AI, even though they weren't.
If that AI is watermarked.
If
that AI includes, watermarking or something else that makes it detectable.
I assume it does. But
I don't think it does right now.
I assume it will.
All
I'm
right.
sorry.
All right.
I assume it will. that
Okay.
You will be successful in watermarking it. How can I make sure my thesis that I've never asked ChatGPT to write, that I wrote and let some commercial product edit that document, and I would be accused of.
Well, I think ultimately you would like, people to just be able to see the fine-grained, truth of the matter, whatever it is, and you should be, I would like a world where you have no problem with saying, like, yes, I use Grammarly, and yes, if you look for a Grammarly watermark, you'll find it in here, and so what, right? But where, let's say, a professor teaching a course would be able to set a policy, and have a tool to uphold that policy, right? And also where, like, I could see, is someone, using a language model to, like, speed up the, attacking my comment section or something like that, right? I don't care if someone is using a language model to do something legitimate, but if they're using it to do something bad, I want to be able to detect it.
Thank you.
Hi, Nadia.
Hi, thanks for the talk. I was pleased that people already brought up sort of ethics and the relationship between sort of people and governments, because I wanted to raise more sort of ethical issues, which is kind of the alignment of the technology itself. So within the cryptography community, I think cryptographers are being asked by governments to build, say, technical solutions that would allow, say, mass surveillance of, say, encrypted data. And the same technology could be used for privacy preserving machine learning, say, to protect our medical data, but still allow machine learning to detect disease. Could also be used to, say, detect child grooming in encrypted messaging or detect inappropriate images. And you can see how that kind of technology could be misused. I don't have a good way of formulating this in a technical way, but I wanted to sort of plant the seeds in people's minds of how the technology that we might be building as a community could be misused for surveillance.
All right, so the seed is planted.
I don't know.
I mean,
Do you have a magical formulation? As
as I alluded to with the, comment about the English as a second language speakers, right? Like just about anything you can think of has good uses and bad uses, right? Right now, there are a lot of people in the AI ethics community who are yelling at OpenAI for not doing watermarking, right? And what is taking so long, right? And, so there's sort of nothing to do that will please everyone, right? If you do it, then other people will be worried about surveillance. But, I feel like, so the ethical question to be answered, to state it as clearly as possible, is, if you use a language model to write something, then should people be able to know that you use the language model? Right? That, boiled down to its essence, that's the question, which, I can't answer, but, which I'll plant the seed for the community to discuss. Yeah. At what cost? Well, there's a very low computational cost there, but
right.
but yeah, of course there are costs to everything.
Yeah. It's
Right.
I'm sorry to cut it off. It's good to end when there's still lots of questions and dialogue. I think we need to let Scott take a breath, and then I guess we're gonna have lunch, and Scott, I hope, is gonna stick around long enough for you guys to ask him in person. Thank you so much for an amazing talk.